So today we're going to be looking at tangents and normals. So first off, what I'd like to do is look at revising what we did last class, which is finding derivatives. So who can help me with this first question? What would the derivative of y with respect to x be? Scan. Sorry? 15x to the power of 4 minus 6. So the second one, what's the derivative of y with respect to x going to be here?
4x minus 3x to the power of -2.
Yeah. Sorry? No, somebody else can do C. Who's going to do C first? Yep.
Y prime equals 3x squared plus 8x to the power of 3
Plus how many x?
plus 8x
Good.
to the power of 4.
Excellent. Excellent.
So I have no idea what to use.
Okay, have you done the IXL homework?
Yeah, I've done all the answers.
Okay. Which is it the second one and third ones?
Oh, I don't know.
There's no way you do the IXL homework and not know how to do this one.
Did you give us a new one?
Last class.
I was taking the tests. Yeah.
So then you've not, that's why. So you need to watch the video from lesson 1, otherwise you're going to be clueless, and do the homework from lesson 1. That's why I post the video. All right. What we're going to look at today is finding tangent and normals. So some key things to remember, some key points, is f of x tells us the y value for any x. So if we look at this curve here, the black line here drawn here is the curve. The coordinates of this point would be this would be the point of tangency that's marked. It would have the x coordinate of some value like a. And what this is telling us is that we can find the y value at that point with f of a. The y value is going to be f of a. So the y value for any x is given by the function. F prime of x tells us the gradient at that point. So at this particular point here, this is what we call the point of tangency, the gradient of the curve is going to be given by the derivative. One of the key things to remember for this unit, is the gradient of the curve at this point is given by the derivative. The gradient of the tangent to the curve at that point has the same gradient. That is crucial, what I'm saying there. So here at point x equal to a, the curve has the gradient f prime of a, the tangent has the gradient f prime of a, and the derivative is what's giving us all of this information. That is the ascension. After that, in order to find the equation for this red line, the tangent, they share the same gradient at this point. To find the equation for that, we use point slope form like this. So all we need to do is we need y minus y1 is equal to n bracket x minus x1. That would give us the equation of the tangent. So we need two things. We need the function and we need the point of x. So once we have the function and the x1 coordinate, we can find the derivative and find the gradient. And then we can use the original function to find the y. Plug them all in and you've got your answer. So a tangent shares the same slope as the curve at that point. The derivative gives us this. So, there's a slight typo here. So m is equal to y prime of a. The gradient is equal to the value of the derivative of the original function at x equal to a. A normal, this is the green line drawn here. So a normal is a line which is perpendicular to the tangent through the point of tangency. This is called a normal. So we can find the equation of this one using the same formula, but we have a different gradient. A normal is perpendicular to the tangent. So we find the gradient of the perpendicular with what? M perpendicular is equal to -1 over f prime of A. Here is all the key information. I'm going to do a couple of examples for you. This is a typical question. You get this one in the exam. Given y equals 4x minus x squared, find the equation of the tangent at x equals 1. So we want to find y1. This is given with the function, so we have 4 times 1 minus 1 squared. What will that give us? That would give us 4 minus 1, which is 3. So y1 would be given by the original function. Here, I'm using this. I'm using this to find that. Next, we need the derivative. So y prime is going to be what? 4 minus 2x. So the gradient of the curve is going to be y prime of 1. That's going to give us 4 minus 2 bracket 1, which is 4 minus 2, which is 2. So now we can put everything into the formula. The formula is y minus y1 equals m bracket x minus x1. So we need y minus y1, we got that, that's 3, equals m, that's the gradient, 2, x minus 1. This is the equation of the tangent at this point.
So you have to explain.
No. If you read the question carefully, it will say, if it says find the equation of the tangent or the equation of any line, this form is accepted. This form is accepted. We can expand it if we want. If you expand this, we're going to get 2x minus 2 and then add 3 to it. So what am I writing? Y equals 2x minus 2 plus 3, so plus 1. If you want to do ax plus b, often it asks for it in general form, which is ax plus by plus d equals 0. We'll do a question like that one in a minute. So next up, we need to find the equation for the normal. It asks us here for the normal as well. So in order to find the normal, we need the gradient of the perpendicular. The gradient of the perpendicular is going to be minus 1 over the gradient of the tangent, which is minus 1 over 2, so it's minus a half. Put everything in again, we get y minus, what was y1? What was y1?
Negative
3. y1 is 3. y1 is 3.
The equation is minus. The equation is minus.
So this is minus 3. What's the gradient we need to use? Scan it, hold down. What's the gradient we need to use? Lucas? No. No. What line are we trying to find? The perpendicular. What is the relationship between perpendicular lines? Negative reciprocal. So we've got minus a half. Minus a half. We just found it. X. What's the x value we're working with? 1. X minus 1. We can leave it in this form if we want. If I just rearrange it, we would have minus a half x. This would give us plus a half, so we get plus 3 and a half, which is 7 over 2. This problem is solved graphically here. This is how it looks.
So is this on the 2?
Yeah. So we have the curve in black line here. The red line is our tangent. Here's our point at 1, comma 3. Look, the coordinates are 1, comma 3. The gradient is 2. See that here? And this is how the perpendicular looks. It doesn't quite look perpendicular, but that's due to the aspect ratio of the thing. Now it does. Now it looks perpendicular. Exam style question. We'll do it together. Okay, start off by doing the first part yourself. Start by finding the gradient, the derivative yourself. Okay, so for part A, we need f of x, f prime of x is equal to, what's the derivative going to be? Oh, sorry, let me try this again. F prime of x is going to be, not taking you, I'm not taking you. That's something else. Guys.
X squared plus 1.5x minus 1.
Excellent, correct.
Thank you.
All right, so now we need to find the gradient of the tangent. Are we going after a tangent? Yeah. So we need to find the gradient of the tangent line at x equals 2. How do we do this? We want our m is going to equal what? Can we take somebody else? You have somebody else? I'm going to start cold calling people in this class if I don't get more engagement.
I have an idea. You can put 2, plug in 2 in the x equation.
Close. So to find the gradient, we need f prime of 2, the derivative. We put 2 into the derivative. That will give us 2 squared plus 3 over 2 minus 1. So that's 4 plus 3 minus 1 equals 6. Take out your calculators in your hands. I'm going to show you a trick here. So getting the answer right here is reliant on getting the answer right in the previous question, but on the test, you don't have to. There is another approach you can use. So we'll use our calculator. So using our calculator, go into your graphing page and type in the equation of the function. So here, press tab and type in 1 over 3 x cubed plus 3 over 4 x squared minus x minus 1. Type in your function.
So when we go to graphing page 7 the function.
Yeah.
The original function.
Type in the original function. Your graph should look like mine if you've typed it in correctly. we ready? Anyone not? Okay. So then move over to your calculator page. Or add a calculator page, we don't have one. Press menu. Choose number 4, calculus. And on the calculator page, look for numerical derivative at a point. For most of us, it's number 1. Cats calculates 4 or 6. Numerical derivative at a point. Our variable is x. The value that we want in this one, was it x equal to 2? We click OK. This template pops up for us. So then you can click your variable button. We type the function in as f1. We want f1 of x. We press enter. That's the answer.
So variable x and then derivative first and then just press OK.
And value choose.
Oh,
So we get our answer 6. Find the equation of the tangent to the line at x equals 2. So we need 3 things. We've got the x value, we've got the gradient. What don't we have? We need to find the y value. How do we find the y value?
You put it to the original question.
So first off, for C, we need to find y1, which is equal to f of 2. We can put that into the original equation, but put it in the calculator now. Do this. Press variables, choose function 1 and type 2 and press enter. 8/3. This is 8/3. So we can put everything into the formula now. We've got y minus y1, 8/3, equals m, which is 6, bracket x minus x1, which is 2.
Sorry. Is 8/3 the y value of x equals 2?
Yeah.
Okay, and that's in the original function.
Yeah.
So you have to write it in that format every time.
This is the easiest format to use, point slope form. If you've got the gradient and you've got 1 point, because if we think about these questions, they're always going to be, you're going to find the gradient, but you're only going to have 1 point. So point slope form is much better to use, and it requires less calculation. However,
You can write it like
most questions will ask you to then form it in a certain form. And quite commonly with these ones, it says, give the equation in the form ax plus by plus d equals 0. So you start with point slope form and then rearrange to whatever other form they ask for. In this one, they're asking for ax plus by plus d equals 0. Now, what's special about this one is it says that a, b, and d are,
fluid numbers.
no, integer. That symbol there means they have to be whole numbers. Which of these numbers is not an integer?
The fraction.
8/3. So what you want to do is if you have fractions in it, at this point, multiply through by the lowest common multiple of all of the denominators. I only have 1 denominator here, it's 3. So I'm going to multiply through by 3. That will give me 3y minus 8 equals 18 bracket x minus 2. Now I'm going to have integers from this point onwards. If you have 2 denominators, multiply the denominators together and then multiply through by that number, and you'll get there. Ideally, lowest common multiple of the denominators, or lowest common denominator. So then we have to move everything around. If we open the bracket here, we're going to get 18x minus 36, 3y minus 8. And then I'm going to rearrange everything. So I've got 18x, move the y across, minus 3y. And then I'm going to add 8 to both sides, and that's going to give me minus 28 equals 0. So this is our answer. Take care of this last point, that you always read what it says carefully in the question. It will say this on the next exam. It will have this on the semester exam. These are favorites of mine. It's very easy for me to write 5 versions of this question.
So is the final exam for this semester or the whole year?
For all IB courses, it should be for the whole course. Every exam is for everything from the start. So the one we have in November is everything since last September. The one we have in February is everything from the first year and a half. And then the one you have in next May is for the full 2 years.
Yeah, but for example, next year we get a semester exam then if we have.
Everything you've had
So
studied.
it will be.
Everything.
Wow, that's great.
So next year, the final exam?
Everything.
Are you gonna be the one writing?
Your final exam? No.
Are you gonna read it?
No.
No, I mean,
IB. I wish.
Oh, no,
we get it.
Okay. So a function is defined by f of x is equal to 2 over x plus 3x squared minus 3. Find the derivative. Have a go at doing this for yourself now. What do we have as our derivative? Yeah. Negative 2 over x squared, good, plus 6x, excellent. B. Find the equation of the normal to the curve, y equals f of x at 1, 2 in the form, alright, so we need to find the gradient first. How do we find the gradient?
You plug in 2 with the variance.
So let's put 2 into the derivative. No, we're not going to put 2 in. What's the x value? 1. 1. That will give us minus 2 over 1 squared plus 6 times 1, which is minus 2 plus 6, which equals 4. Is this the gradient that we want?
Yeah.
What type of line are we finding? What type of line are we finding? Read the question. The normal. So how do we find the gradient of the normal?
Negative reciprocal.
Negative reciprocal. And that would give us minus a quarter. How do we find y1?
You would you plug in 1 into the original function.
We would normally plug 1 into the original function. So we would normally stick 1 in here, into this. Why don't we have to this time? Do we already have it?
Yeah.
Where?
And the quadrants.
The question is saving us some time. Actually, no, the question is stealing an easy point from us.
Yeah, how good is it?
It's not saving us time, it's stealing an easy point from us. It's thinking, I'm not going to give you a point for that. It's too easy. So let's put it into the equation. Oops. Oopsies. I need to start using the phrase "oopsie-daisy" more. Very British.
It's dancing.
Julia Roberts particularly likes Hugh Grant when he uses it in Notting Hill. So, oh, it's so quaint.
Nothing is amazing.
There's nothing like hamming it up.
Yeah.
I need to ham up my Britishness more. Okay, so we need y minus 2 is equal to minus a quarter, bracket x minus 1. Now we need to rearrange to get it into general form, so get rid of the fractions. What do we multiply through by? Let's multiply through by 4. We'll get 4y minus 8 is equal to negative x plus 1.
So this is how you should talk.
Yes, please, I learn more.
No, I think I'm going to talk more in my normal accent. It'll be a little bit better, because when I was like I used to talk a lot more like this. No, I'm from Yorkshire.
Yeah.
So I'm just going to rearrange it a little and make it a bit more straight. So I'll add x to both sides. I'll get x plus 4. And then I got to subtract another 9 from both sides. If I take another 1 from both sides, I'm going to get minus 9 equals 0.
That's the answer.
I can go a little bit. Alright, I can go a little bit further south if you like, and do more in the Union accent. So we can go to Union next with the next question if you like. It'd be great, one. I'm going a bit scout there on that.
Was I
Sorry,
also
also
going
chicken.
Like, was that how you talk?
Okay, X is, that's it for today.
Okay.